Hello, thank you. So I'm François Brument. I'm coming from France. I have a company called Studio In-Flexions, and I'm here to talk to you about printed habitat. Printed habitat is a large-scale 3D printing project that I've been leading with a German company called VOXELJET, which allows you to make some large parts. But the aim of my talk will be more about discussing about 3D printing bring new opportunities, some like the previous speaker told about design, changing freely the design of your object. So what that means when today I'm able to change, for each production, each fabrication, changing the shape of my object. So what does it imply as a designer? I've learned about design, about creating one same object for everybody. This is due to industrial process like 100 years ago. And right now, what happens when I can print each time a different object? So our company is called In-Flexions. It's a studio based in Paris, and most of our work is around 3D printing technologies, but also creating digital applications to help you to, for example, have an idea about your electric consumption. And then other aspect of our company is to create some application that allows you to customize your objects. So what I want to talk to you about is something that I call a digital process. 3D printing is nearly like the end of the process, is where you're gonna fabricate your object. But 3D printing is nothing without digital conception. And keeping a fully digital process from conception to fabrication allows you to shift from standardization to mass customization. For example, here you have a series of chairs called Chair 71, and you have some like an infinite variation of those chairs. Those chairs were built like 6 years ago at Materialize, and none of these chairs are identical. It's easy to say that. A lot of 3D printer manufacturers will tell you you have the ability to create each time a different object. But what happens if I have to always design that object? Yeah, we were talking about the speed of 3D printing, but what happens if the designer takes 2 days to make the object? So maybe for 8 chairs, you're gonna have to spend like 2 weeks long. So I think the major idea here is that to be able to take the unique intelligence of a computer, which is computing, calculate fast and fast. So what happens is if, as a designer, you can change the way that you are conceiving objects and thinking them about as dynamical object, where you can, whenever, change the size of your 3D model, the size and shape. For example, here I've been developing a tool that allows to change the structure of the chair. Like 6 years ago, when I built those chairs, few people were able to tell me, you have to do this to make a 3D printed chair, because we didn't have at that time enough knowledge about resistance, about that material for 3D printed, let's say, everyday objects. So my aim was to find a way to create some different structural patterns, but I didn't want to design precisely all of that patterns, because I could have spent times and times to make one and then a second one. So here I've made a program that allows to generate an infinite possibilities of those patterns. And for example, those 3 feet, this were like key parts of the chair, because I wanted those chairs to be able to be seated on. So I've tried to find some various solutions, and those were generated by the program. I made a program that keep the same shape always, but always changing the structure. So what you have seen here was purely generated by the computer. I've designed the system, but let the computer create the solutions. Having a dynamic process allows me to think so, but why should I keep that dynamic process for me and not bringing this to the user? How can creating an object could be something that we can share and where the user can have his own experience. So this is the example with Vase 44, which is a project where the vases are created through the sound of your voice. Rules are simple. The louder you will speak, the wider will be the vase. The longer you speak, the higher they will be. And then depending on the sound frequencies that you are playing, it will change the overall shape of those vases. We wanted to work with voice because voice is a really intuitive tool. What our discuss is not to say, let's create a 3D modeler program and where everybody will be able to make its own object. There are a lot of 3D modeler right now, and I think that my aim as a designer is to keep creating and offering user a useful object, but letting him the opportunity to transform it. So here, for example, you see that there are some variation of it. And for example, the first one downstairs are just some louder but short sounds, while the other one are longer sounds. So it's easy to play with the tools and to create your really own version of the vase, and depending also precisely on the needs you want, if you want to have a lower vase or a bigger one. We've kept trying to find some intuitive way to play with 3D models. And here we have been working with Microsoft Kinect. You might have heard about it. It's a device that allows you to play video games with your body. So here the idea is to change the model directly with your hands, and also the camera is able to grab some colors. So here you have a really intuitive way to modify the shape of a lamp and also its color simply by interactive. You will see here that the shapes may look like a bit complex, but also a work for a designer is to find a way to bring such complexity, but effortless. How you can bring that complexity without spending years and time. So here the user is really playing in real time and the shapes evolving directly. So that means that if you want to bring some customized solution to user, they might have the possibility to understand how it works. For example, if I move my hands like this and then I wait for 10 seconds to see the result, I will never be able to understand what happens. So bringing some customization means also bringing some knowledge and interactivity. So Printed Habitat project is the same approach, is how we can bring some really personal solutions inside your home based on digital conception and digital fabrication. How can I reach to have like a dynamic system, a system that can adapt to whatever solution? I think that coding can become a new tool for designer. It's not can become. I'm sure that coding is a new way of creating, of conceiving design. For example, here coding allows me, for this Printed Habitat project, to create an overall organization. And then later on, the software will be automatically bringing all specific parts, combining them together. We will later on understand what it is, but here, as with the chairs, I never designed precisely every part of the Printed Habitat project, but I let the system organize it by itself. The other aspect for sure is fabrication. Fabrication here was made possible with VOXELJET, who has created this large-scale 3D printer that allows you to print like 4 meters long, 2 meters wide, and 1.8 meters parts. They are working with sand materials. So what interesting, we were talking about the cost of material. Plastic material are nearly like $50 per kilo, while here it's around $50 per ton of sand. So here you have a really, really big machine and with a really, really low-cost material. I'm going to right now show you how Printed Habitat project can be sought into your space. There are two possibilities. I will say that the first possibility is that you have an existing space and you want to optimize it. For example, you have 2 children. They have before like 2 stacked beds. Right now you want to have a room from each of them. 3D printing allows you here, for example, to stack the bed together, but having the wall which is bending. And then later on in this large wall, you can integrate, for example, toilets and showers. Another opportunity and solution is to say you have a free space and you want the printed habitat to be organizing that space. There you can have, for example, here you can combine all spaces together, the room side, dressing side, shower side, and bookshelves together in just one single process. We're going to have like a room view of the project. This is the overview. Here you can see how the room side is just connected to the dressing side and the shower side. And what's really specific here is that, for example, with 3D printing, you don't have to think about construction modules are rectangular modules, orthogonal modules, but here you can bend in every direction. And moreover, you can think about how you're going to work from the outside of the modules, but also from the inside. So you see, for example, here, bookshelves are already integrated into the wall thickness. Printed Habitat project is at the encounter of design scale and architecture scale. You see here, for example, there are some hooks, some shelves, and this is all combined together in that partition system. Here is the shower side. We were talking about materials right now. Here we have thought about, there are right now post-processed, like ceramic post-processed, that allows you to have some waterproof resistance on material. So what I've explained to you is that coding right now is the main main element of the project. So what I've coded here is like I've told you, like prior to Printed Habitat project, for example, you will be working with bricks. Let's think that right now we are working with a virtual brick, and this brick can change its shape and its size in whatever way you want. We are going to look at the parameters right now that should be able to combine them together. Here, think that your element can be is not only orthogonal, but can shift in every direction. You can work from the inside or the outside of the material. You can choose, for example, an aesthetic on one side of your room and another aesthetic on the other side. You can also create some aperture. All those elements need to be thought like to be able to be combined together. One other opportunity is to be able to work from the inside and bring some electricity or water flow inside. And then later on, if you bring electricity, we are able to create all smaller elements like switch and plugs, for example. And here we are talking about the post-processing to create some more waterproof area in the project. So all of those, there were like nearly 7 parameters, but there are a lot more. And that means that as a designer, I have to find a way how those elements can be combined together. One really, really great opportunity of 3D printing, as I told you, is the ability to be able to create each time different shapes. So, for example, with the chair or the vases, we are creating each time a new object, which is based more on your needs and on your taste. But here, it's also become really powerful to use 3D printing because you might know that, for example, I've seen some in Shanghai, like a IKEA factory, IKEA shops, where you can buy some industrial modules that are furniture that you have to combine together. But you always have to combine like standard modules, and then later on, most of the time, it's too short for your space, or it's too long, then you have some empty space. Here, you can precisely create whatever space you need, and the software plus the 3D printing technology allows to create what you really need. Those are the very first blocks that were built in Germany. So they are like 80 centimeters block. I told you that the machine is able to create some 4 meters long parts, but unfortunately in Paris, in France, but also I've seen here in Hong Kong, you are living quite high enough, and it's not possible to lift like a 4 meters long part. So it's clever to split all that module in smaller size in order to be able to lift it, to be able to bring it in the widest opening of your home, and moreover to be able to stack them together by just the strength of your arms. So these are nearly the 60 modules when they were produced. So all those modules are tightened together with a quite simple process, which are threaded rods and nuts. The first thing you have to do is just to fix some first threaded rod on the floor plan, just to have the right plan. And then later on, you just tack the part on top of the other one. And here, for example, you might see that all our threaded rods are only verticals, and you might see that the pattern, the aperture are not that vertical. So here it's also the software that allows to, for example, create those small apertures. It's just distributing the aperture from one side to the other side of the threaded rods. Like this, you leave the intelligence on the software to have a really real organization while thinking about, I need to make an aperture here, another one here, another one here to be able to make this. No, here it's fully automated. Regarding to the cost of a project like that, today it's quite too early to speak about cost. I told you that 1 ton of sand material is nearly like $50. VOXELJET is right now working on a concrete material. I hope that this concrete material will be in the same price range. But here, just understand that if we spend, for example, let's say 3 days to conceive the project, to have like one solution, a second one, a discussion, then few days to think the project. The whole project here, when it's disassembled, it represents like a third of the full machine. So the full machine we can build the full machine in like 3 days. So there is nearly 1 day of fabrication here. There are some few post-process, but we can say that in nearly 2 days, everything is fabricated. And then later on, when we assemble this like in 4 hours. So that means that in nearly 1 week, it's able to bring all of this inside your home. While if you use some standard, traditional way of building such a thing, it could take like 2 or 3 weeks or nearly 1 month. So I think that we must understand that economy around 3D printing is you have the cost of the material on one side, but also try to think about the time you can earn with working with 3D printing. So this is the first prototype that was made. As you may look at it, it's just the exact representation of what was previously some 3D renderings. It's just the same what I've been seeing in my computer for months and months. It became real, and it became real exactly as on my computer screen. Here, for example, you can see the various aperture, and you have some shelves here. The strength of 3D printing, one more time, and digital conception, if, for example, you want to bend more your wall, the shelf will be adapted automatically. And one other aspect is that later on, this is your first project, and then 2 years after, you want to have a longer bookshelf, for example, we are able to take some parts out and then to reprint some more, and then you can extend your previous project. So this is what is really interesting in keeping the whole digital files through the process, is that you can change whatever you want and then update the project. Here you can have a view on switch and plugs. Those are supposed to be built in plastic, and they are supposed to be conceived according, especially on the aesthetic you want to have, for example, or whatever bending of your wall. It's the same thing for the hooks, for example. Here, none of the hooks was especially designed to be there and one other there. They were automatically shaped by the wall itself. Regarding the horizon of this project, right now, we are still working on the development of that project, but I think that there are right now clearly two ways about how we can thinking about using 3D printing inside home area. One scenario is like the B1, the one that you saw, is that building the part in a factory, then shipping the parts on-site and fabricate on-site. While, for example, if you want to make a larger home, we could think better about moving the printer on-site and then being able to build some 4 meters long parts and connect them together just on-site. I want to thank you for inviting me, and I have to thank the VIA, which is a French organization that helped me and gave me a grant to make that project, and VOXELJET, which was really implied in that project development. Thank you.
Some questions for François. Okay, I'm going to jump right in. You were talking about how 3D printing has changed the nature of design practice, and you, like me, learned a certain way to design things based on traditional manufacturing. Have you given it any thought to how design education would change, and what would be the things that you would suggest students today study in preparation for this new approach to creating things?
Yeah, it's a nice question. There are two aspects. One is, for example, is for sure skills. I'm saying that coding is becoming a skill for designer. There are some various ways of coding. You can code directly by coding and typing code, stuff like that. There are right now some other software that we call parametric software, which are you have to create some programs with visual functions. But I would say that, moreover, I think that the biggest difficulty is that when you are a student, my aim is I am a teacher. My aim is to teach you the practice when you are getting out of school and for the next 10 years and 20 years. But I have a digital practice. I'm teaching in 2 schools, but I would say that my practice is nearly 5% of the global practice. So I understand that it's quite difficult for students right now to think about learning and learning what they are going to use just getting out of school and what they are going to do like 10 years after school. So I think right now it's the cultural aspect of design. I started to learn design like 20 years ago, but I remember at that time there was a great project in Japan, the Yokohama Port Terminal. That one was fully digitally conceived. It was 20 years ago. But when I started my practice, every teacher told me how to use the pen. I'm not saying that 3D printing and computer is forgetting about pen, but it's just thinking how you can take the most efficiency of every tool.
Okay, thank you. Other questions?
The material for that large printer was some type of sand. Could you explain what the material is and what kind of finish it gives you after it comes out of the machine?
Yeah. So the material so VOXELJET right now is offering 2 materials, the sand material and the plastic material, which is a polycarbonate, a PMMA. And well, at the beginning you have seen about it, it's just powder. And this powder is just a little bit modified to be able to react by 3D printer heads that create like a chemical reaction. So the project here was made in plastic for shipping reasons, because we've been exhibiting this quite often. But what's interesting is that all the parts you have seen were like painting, like whatever wall is painting here with a roll like that. So it just here, I think it's also quite a complexity or quite how I can say it. I think that I was saying about 3D print earning money with 3D printing is earning time in a way. So I think we have to find some clever way to make some really nice finish and aesthetics directly out of the printer while putting some more and more post-process. So here it was, because the VOXELJET machine allows to make some really long parts with a great resolution. So this is what was really easy to work with here, is that just one layer of painting and it was done. So
We have time for one last question.
I'm curious about the strength of the structure. Will it withstand like earthquake, or will it be weight bearing? Or
fortunately in France there is no earthquake, but I will say that I told you that what you might have seen here, mostly the outside of the object, but all the let's say the bricks were thought as rigid bricks. So inside of them, they are really structured from the inside. They are in a way lightweight and really structured. So the wall system is really strong enough, and then it's also tightened directly from the wall. The first rods are tightened in the ground, so it's really tightened to the ground. So this is quite like a strong element, and later on, if there is an earthquake in Paris, I will tell you about earthquake.
Thank you very much, Francois.